Welcome to Sachin Study Tech. Today topic is little o notation. It is used to describe an upper bound that cannot be tight. That means it is a loose upper bound of f of n. So f of n grows slower than g of n. Slower growth rate here. Let f of n and g of n are the functions that map positive real numbers. You can say that the function f of n is little o of g of n if for any real positive constants, that is c, there exists an integer constant n naught less than or equal to 1 such that f of n greater than 0. So you can see here the limit n tends to infinity, f of n by g of n equal to 0. So you can take any value f of n function and g of n function. So f of n is slower rate than g of n. Now we can consider, for example, f of n is n, then g of n is n square, or f of n is n square and g of n is n cube, or f of n is n cube or g of n is n power 4. So like that you can consider any value. Okay, then check the whether f of n equal to little o of g of n or not. So I am consider f of n is n square and g of n is n cube. Now limit n tends to infinity, f of n by limit n tends to infinity, f of n is n square by here g of n is n cube. Okay, now it is limit n tends to infinity, that is 1 by n. So n value is infinity. Now we can check here, n value is infinity, limit n tends to infinity, that is 1 by 0. Infinity can represent 1 by 0 here. It is 0. So that here it is satisfied. Then you can write f of n equal to little o of g of n. And next one is little omega notation. Here it can represent by using this symbol. It is used to describe loose lower bound of a f of n. It is not a tight lower bound. Okay, that is a loose lower bound. Okay, faster growth rate here. F of n grows faster than g of n. F of n equal to omega, little omega of g of n. Limit f tends to infinity, f of n by g of n equal to infinity. Now we can see here f of n is the n cube and g of n is the n square in reverse. For example, you can take n power 4, f of n is n power 4, here g of n is okay n square or n, or you can take any value less than that. But here f of n is n cube and g of n is n square, because f of n is grows faster than g of n. So f of n limit n tends to infinity, f of n is n cube and g of n is n square. Here limit n tends to infinity, that is n. So what is the value of n? The value of n is the infinity here, infinity. Now it is satisfied. Limit f of n by g of n, limit n tends to infinity, f of n by g of n equal to infinity. So that you can write f of n is little omega of g of n. Now you can see all these 5 notation in one slide. Here the big O notation and big omega notation. Here it is a theta notation and a little o and a little omega notations. Now we can see, so big O notation, it can represent the upper bound on the growth rate and it represent lower bound on the growth rate. Here theta notation, it is a average bound. Okay, that is a tight bound here. It represent little o represent strict upper bound. Here it represent strict lower bound in little omega notation. Okay, it is used to worst case time complexity. Can calculate the worst case time complexity by using this notation. Okay, best case time complexity you can use the omega notation, and it is a average case time complexity you can use the theta notation. Use when an algorithm is strictly better than upper bound, you can use the little o notation. Little omega, it is used when an algorithm strict worst case than lower bound, you can use the little omega notation. Now asymptotic upper bound, here at asymptotic lower bound, here it is a tight bond, and here little o if it grows slower than another functions. Now we can see in mathematical representation f of n equal to big of g of n. Okay, 0 less than or equal to f of n less than or equal to c into g of n for all large n. Mathematically represent in big O notation, here f of n equal to omega of g of n, that is 0 less than or equal to c into g of n less than or equal to f of n for large n. And mathematical representation of theta notation, here f of n equal to theta of g of n. Okay, 0 less than or equal to c2 into g of n less than or equal to f of n less than or equal to c of n. Okay, g of n for large n. So mathematical representation here little o and little omega, limit n tends to infinity f of n by g of n is equal to 0. Then you can represent little o notation, f of n is a little o of g of n. Here limit f of n by limit n tends to infinity f of n by g of n, that is equal to infinity. Then you can say that f of n equal to little omega of g of n. So these are the major difference between asymptotic notation each and every one. Okay, thank you for watching this video.